next presentation, the title of the following presentation is Blockchain in Legal Metrology and Inter-NMI Network. Ms. Mahbooba Moni from PTB will be the speaker. Since 2019, Mahbooba Moni has been a scientific employee of, I try only once to pronounce this, Physikalische Technische Bundesstaat PTB in Germany, in the area of legal metrology. She has worked on cutting-edge technologies to improve the security, privacy, and scalability features of blockchain technology. Using the Hyperledger Fabric framework, she also expands her expertise in designing private blockchain applications. Mahbooba actively supports and works with national and international notified bodies to test, examine, and implement the smart contracts. She received her Master of Science degree in Communication and Media Engineering from, Hochschule
Offenburg. Yeah.
Okay, Germany. Welcome, Ms. Mahbooba. I hope that I pronounced your name correctly.
Yes, thank you.
Go ahead with your presentation.
So can you see my screen also, Rodolfo?
Yes.
Okay. Thank you very much, first of all, for inviting me. Yeah, so I will start my presentation. So in my next few minutes, I will be talking about what is the digitalization relationship with legal metrology, also how we are actually developing some applications using blockchain. So till now, we have two types of use cases which used this blockchain application. So in Germany, particularly, we are more concerned about privacy. So also that's why we also need to provide more security and privacy stuffs for these applications. So one of the major smart meter is a topic for the legal metrology field. So they try to also improve the security features for the smart meter, which is also a part of legal metrology. And another use case is already Jan was discussing about it, that public key infrastructure for smart meters, so which we actually collaborated with InMetro for this project. And we will be discussing about implementation and results time to time. Yeah. So basically what happens in the legal metrology area is that there are a lot of measuring instruments coming in, and all of them maximum has this cloud connection, and which actually require the new solutions to cover the requirement, and also which is related to the legal metrology field. And that's why we need to develop some kind of innovative solution which can extend and merge these novel technologies. So why blockchain technology? Because last 4 and 5 years, there were a lot of interesting work going on through this technology, because it gives you this immutable append-only data structure, which is also providing us a lot of transparency. And basically all the blocks are cryptographically linked, and it also provides some kind of platform for distributed systems. And there is a term for a smart contract, which is providing the execution and automation of the workflow. So you can write your logical preparation in that smart contract, and also use that in time to time for the executing the workflow. And another important feature is that you can actually establish the trust where there is no trust need. You do not need to trust each other, but you can trust the independent parties. So that's why blockchain technology is also interesting for PTB to research on this area. So by considering that in our mind, as we were also focused on confidentiality of the client section, and also we wanted to make sure that how can we improve the privacy, because in blockchain, as you already know, that it's public. So it can be public and private, but like mostly it is the use is that it will give you the transparency. So you somehow need to give some information as a public. But at the same time, when we want to use it in the enterprise section, then we need some kind of privacy. That's why this private blockchain stuff came in. And PTB, and also I think in National Metrology Institutes, there we are mostly interested on private blockchain, so that we can also ensure the privacy. So how can we actually give the blockchain as a privacy? So we try to also go through a lot of cryptographic materials like homomorphic encryption, functional encryption to enhance the privacy in the blockchain. So we combine these two technologies. So why it is needed? Because in the market also there are in current, especially in the when as a regulating authorities, when we try to verify the software in this current state, we have this system. We check only the system integrity, and mostly the hardware is physically sealed. And we also check this integrity by calculating the checksum over all the files. And this checksum can be manipulated without even breaking the seal. So to prevent this, actually, the authorities regularly require the recertification to do this. And also, it is sometimes inconvenient for the stakeholders, because even for the minor correction or minor bug fixes, you always need to go through this recertification process. So what we need then, we need a verification method which can verify the binary image itself, not only the binary image, but also the functionality in that particular system. So for our proposal was that we wanted to propose an alternative model for a smart metering system, which will be a combination of functional encryption and blockchain technology. And why we want to do this? Because, of course, a smart meter is a very complex system when you add the security in that stuffs. So our aim is also that whether we can reduce the complexity itself, so that we can achieve any high-level metrological security and examine all the possibilities and limits of blockchain and functional encryption for this simplified model. And our target was to give the solution which can give us the data authenticity of the measurement results, and also the privacy of the measurement result. And so that we can integrate, also another is integrity of the algorithm, establishing confidence of correctness of measurement. So in this particular use case, we proposed a concept. This is basically the classic smart metering system, which has a lot of it can consist of several sensors that actually produce measurement values in given time intervals. And in this particular use case, we actually considered that these sensors are classified as trustworthy. And it is already regularly checked by the market surveillance for the manipulation. And from here, the sensor is actually connected to the gateway directly. And there are provider who is actually basically the energy providers, who is actually interested for the consumption of the customer. And at the end, they need to provide the billing to the customer, and customer who is actually consuming the energy itself. And some other application for the displaying the results can be there. So this is a typical classical system, mostly. And there is a gateway. So gateway actually here represents the central unit, which is basically storing and further processing of this measurement data. So typically this happens. And so in this model, we wanted to integrate the blockchain. So blockchain actually we wanted to use as a immutable and redundant storage for measurement data. And also we will implement, we have implemented already the functional encryption to maximize the privacy of measurement data. So, okay, I already talked about functional encryption, but what is it actually? So functional encryption is also similar to homomorphic encryption, so which actually allows the calculations to be performed on the encrypted data. So if you see from the picture here, the customer has kind of a secret key, and customer has actually the owner of the measurement data in this case, yeah, because he generates the measurement value himself. So he generates a secret key and public key by himself, and he shared this public key to the sensor. So sensor actually kind of insert any measurement data with its public key whenever he or she sends the data. It sends the measurement data. And customer because in functional encryption there is an algorithm. So with these algorithms in this customer also can generate with his secret key. There is an evaluation key, but that is separate, and this evaluation key is actually kind of created by the tariff model. Suppose some provider has some different type of tariff, so this will be mutual consideration of both of them, and this evaluation key is generated by that lot of algorithm stuffs. And in this case, actually, when so we get the results from we get the measurement value from the sensors, we know. And also, when the provider is seeing that your customer is generating this much of amount of energy or this much of measurement value, he can actually use his evaluation key to decrypt the results, because he only need the billing result, that how much he or she has consumed. So he needs that amount, and that actually can be because in functional encryption you perform all the calculation on encrypted data, but you decrypt when you because it provides, because in the decryption method it actually give you the plain text result as a calculation. So this way we actually try to guarantee the integrity of the algorithm, that evaluation, because evaluation is key is tied to this function. And also we combine this blockchain technology in this system because we wanted to give the transparency, and also it's a kind of a storage system in our case. So also we used Hyperledger Fabric for the blockchain framework implementation, which is already hosted by Linux Foundation. And to use this, because first of all it is permission based and it has modular architecture, and it has membership service provider, which is actually generating some crypto materials and giving some private credentials for each clients. And also it has channel feature, means like, interestingly, you can really integrate different nodes, but they will be just talking with each other. But if I don't want to share my stuffs to other, I can also hide. And there is a smart contract facilities, which is using chain code, and there are some endorsement policies. So that's why we chose Hyperledger Fabric for our project. So what is our goal for this implementation? What do we want to achieve actually? Basically, we wanted to find the performance blockchain bottlenecks of minimal configuration of Hyperledger Fabric, because it's a huge framework. So we need to really focus on that, where I can get the maximum amount of help from Hyperledger Fabric. Yeah. So this was also important, that we get we do some performance test, so that we are sure that what we want to achieve, whether it is overheading our system or it's just fine, that we can use it. So this was the goal. And also we wanted to check the feasibility, that in given limitation, like if we wanted to reduce any computing capacity of measuring device or even timing, how it affects my system. So, and for this, we actually, it was like really hopeful results, because it was, although it was not that we really implemented in a smart meter gateway, but we tried to do this in computational tasks, so that we can some kind of we can show that this proof of concept is working. So we tried with, first of all, 48 clients to in different multi-threaded system, and when the parallel instances were working, so we kind of tried to measure the maximum CPU capacity. How much is it taking the space consumption, or how much is it really working or how it can break. So in our experiments till now, when we get the perfect results up to 8 clients, which is still feasible because in a smart meter system, the measurement value actually needs to, because you need to get the value in 15-minute interval. That is natural procedure. So even if my whole blocking, adding stuffs is taking time, it's still it can be a real life solution, because we have that calculation that okay, if we give suppose if I wanted to measure the value, whether it is integrated in timely or it taking too much time. So in minimum condition it is still working fine, but of course we need a lot of work on that. And also we need to check that when we use some high computing capacity, whether how this blockchain stuffs work. So by having this mind, we have this use case too. So where all the we wanted our fellow colleagues from Wilson Mello from InMetro. It was really nice working with him and Richard Machado. Yeah. So this PKI staffs was also another task, which was also collaboration from with InMetro, because we were aware that in InMetro they were facing these issues that they really need to implement this PKI in blockchain systems to prevent the fraud. Yeah. So I will just shortly go through this PKI, that what it is even. So basically for the smart meters, there should be a need of digital certificates so that you can trust that this is smart meters is authenticate and this is the real smart meter. And there is in PKI system, there is always like certificate authority and this register authority. So certificate authority, they issue, they stores and sign the digital certificate. And for register authority, they verify the verify the identity and the interface between the CA and the user. But there are some drawbacks of it, because in CA-based PKI, you have to always depend on this trusted third party. Yeah, and to manage the digital certificates also sometimes it can be complex, because you need to generate public and private key, and it's really sometimes difficult for the measuring device, which are not very computational high. So it can be expensive for those type of device. So we need some kind of solution that how can we even achieve. If we want to improve our security in this type of device, we need to also provide some solution. So for a smart meter also, if we want to give this PKI system, it is of course very beneficial, because it will increase the integrity, authenticity, and non-repudiation. And also, of course, it will improve the reliability, because PKI is, of course, a very well-known and secured system. And so also in legal metrology, it will improve the control activity, which is already software controlled measuring instruments. And it will help to prevent frauds and tampering with measurements. So basically in traditional CA versus blockchain-based PKI is there is because in traditional CA based you have this manufacturer who requests the digital certificate and provides the public key, and he comes to the register authority for to check his information, and register authority inspects a smart meter and endorses the request. Then it goes to the certification authority, and he or she issues the digital certificate and attests to verification. And when this smart meters have this certification, then society is trusting that, yeah, I trust CA, I trust RA, I trust the digital certificate, and I trust the smart meter. But we just try to give this alternative solution as a blockchain based, because in manufacturer, this is the same procedure, but here the permission endorser is checking the information, inspects the smart meter, and endorses the transaction. But here actually we are eliminating the certification authority, because we don't need it here to issue the certificate only, because the permission endorsers in Hyperledger Fabric or in blockchain-based system, he is already doing this task, and he is adding this valid block to the blockchain system, and society can then check the blockchain system, because we consider that each one has that node and peer, and it doesn't have to be a very high computing device or something. It can be just one node. So this is how they can check the blockchain system, and they can trust the smart meter. So proof of implementation, concept implementation, we did with the elective card digital signature algorithm, the whole system. And so the registering of the smart meter is also on blockchain. It stores, and permission endorsers inserting the public keys. And a smart contract is written in Hyperledger Fabric, which verify the digital signatures and receive the meter ID and signature digest. So here is our Inter-NMI network currently. So basically, we have 5 nodes right now. So from PTB, one is Germany, another is Czech Republic, then NMIJ, and then Malaysia, NMIM. There is one virtual node from Microsoft Azure, and from Brazil, of course, Brazil, we have 2 nodes. So we have this 5 nodes currently running. So everybody is actually connected to PTB, but what is needed is like we wanted to integrate all the nodes to each other. So that why it is needed, because blockchain needs a more scalable solution, because it takes time, and when there are a lot of nodes are connecting with each other, we can really test that what is the bottleneck of performance. So this is how we are working. So, and one experimentation already went for orchestration tool, and this is within Metro we have done. So in Hyperledger Fabric, there are three type of implementation. One is like you can use the Docker container to run the system, but you can use the peer node individually. You can use the single node. But like also there is an orchestration tool which helps you to give the physical things as a virtualization stuff, so that I can run many nodes in one PC to test. So, and also we are using kind of Hyperledger Explorer, which is a tool which comes from Hyperledger, which gives that performance test we can see as a visualization. So this is one, and this type of when we implemented this PKI, especially for the blockchain stuff, so we actually took blockchain as a store and attached the public key from smart meters, and meters sign their measurement with their private key. And for this, there is no extra cost for digital certificates, because you don't go to the certificate authority to do these stuffs again. And also it doesn't depend on trust third party, and blockchain actually do not eliminate actually PKI, but it is interdependent technologies. Yeah, thanks.
Thanks, Miss. Thank you, Miss Mambulo.
I wanted to finish a little early because time.
Yes.
Yeah.
It's good to work with people in Germany that they keep the time very strictly. Let's see, there is a questions on the chat. If someone intend to make a question, you could put on the chat to, and Miss Money will answer the question. Alexis Falke asked, when the system is working, the workload for the NMI will increase. I suppose that the workload of the internet.
So when the system is working, the workload for the NMI will increase. It means like the workload for the employees or workload of the system.
Alex, could you make the question on the microphone?
Yeah.
Yeah.
So I understand that the system has the consequence that you will not need any certification body anymore, but the certification bodies are fulfilling a function And this is taken over only by the blockchain, or is also taken over by the NMI? So the NMI has to do more tasks than it is doing today?
Because I get it. Because when you see there was registration authority, and that is basically kind of NMIs. Yeah, we check and then we say that this system is valid. So it's not that when we are not taking over the work from CA. So we are basically eliminating that with the technology itself. Yeah, in this particular example. So this is of course to reduce the workload itself.
So because
register
when something is not functioning well, the technology will not help. Human beings and to intervene, and this is done by the certification bodies today. So what happens if something is not working well, or there's some questioning, then that will be taken over by the NMI. That is more work for the NMI.
Yeah, but it's a system we are trying to develop. Yeah, so if it works perfectly, because when certification authority, because they can be also manipulative, right? Sometimes. So the workload, I think it will be topic of next 5 years, right? if we really implement this.
Well, the project of that Mr. Jean Martinez Mr. Jean Martinez speaks is about is a kind of smart meter, and the idea is to remotely discover where are the suspects of doing fraud or some bad thing in the gas pump. So it will help. The idea is to help the NMI to pinpoint the place that we are going to send a person, metrologist, to see if it's all right or no. So that the idea is making a smart fiscalization.
Yeah.
Anyone else would like to make a question? I have one. What type of smart meters are you considering to first use to implement to make a pilot or test project?
Probably the electric meters is the most topic in Germany. Yeah, electric meter. Mm-hmm.
Yes, in the case of Brazil, the project that we are discussing of gas pump starts 15 years ago in electric metering. But the price of using the PKI, we don't. It's about $30–40 using these detectors. From the $10, less than $10, if it is the less expensive possible with a large customer base. But nowadays it's about is a starting project. The new process is about $50 increase in the price of the product. So that this is it's impossible to increase $50 in a customer smart meter because of the price of the product. We have a lot of considerations of price.
Yeah, it's same here also. Because that's why we wanted to use the technology that we can also reduce the price and not the electricity price, like the system we develop, somehow we can cut down the price from there to increase probably somewhere else.
Okay, anyone else has a question? Let me see. I don't think so. So thanks, Ms. Mabuba, for your presentation.
Yeah, thank you very much.